In this paper, we propose switchable primaries that allow the photographers to change both the number of color primaries and their spectral transmittance, resulting in multiple switchable operational modes. Current commodity color cameras use color filter arrays, or CFAs, where the number and spectral transmittance of the color primaries are fixed, usually narrowband RGB primaries. However, different scene conditions may demand different primaries. For example, when capturing dark scenes, broad CMY color primaries result in better signal-to-noise ratio than narrowband RGB primaries. RGB filters, on the other hand, provide better signal-to-noise ratio and color fidelity for bright scenes. Similarly, cameras with more than 3 color primaries provide better color fidelity for colorful scenes, trading spatial resolution for greater color fidelity. Therefore, cameras with fixed CFAs cannot provide the best picture quality under all scene conditions. Instead, we propose the use of 2 shiftable layers of CMY color filter arrays, one on top of another. The combination of these 2 layers result in a CMY color filter array. Next, if we shift the top layer one tile to the right, different tiles superimpose, resulting in an RGB color filter array. Now, if we also shift the top layer by one tile in the vertical direction, the superimposition creates 6 different tiles: R, G, B, C, M, and Y. Hence, different shifts of the layered CFAs allow us to switch between CMY, RGB, and RGB-CMY modes in the same camera. Such switchable capture modes can be used to achieve optimal signal-to-noise ratio for both dark and bright scenes. And also to achieve higher color fidelity. By using RGB CFAs, such shiftable layers can also be used to obtain a camera that can switch between LDR and HDR modes. Here we create low transmittance wideband filters by superimposing 2 different narrowband RGB filters. Without shifting, similar tiles overlap, resulting in an RGB LDR mode. After the shift, alternate columns capture the lower and higher ranges of the brightness, providing a high dynamic range mode. In the paper, we show that the problem of finding the arrangement of the tiles and the amount of shift can be posed as a constraint satisfaction problem. For example, in our camera with switchable primaries, if we restrict the shift to be in only one direction, the CSP solver would return the following patterns and shifts. Here, no shift results in a CMY CFA, one shift to the right results in an RGB CFA, and 2 shifts to the right results in the 6-color mode. Similarly, for the camera with switchable LDR and HDR modes, if we constrain one layer to the Bayer pattern, it returns this CFA. No shift results in a Bayer CFA for the LDR mode, but one shift results in the HDR mode. This constraint allows us to design an add-on device for existing LDR cameras to provide switchable LDR-HDR modes. As a proof of concept, we simulate shiftable layers of CFA by time sequential capture of images from a monochrome camera using different layers of dichroic filters and extracting the appropriate pixels from each of these images. We also provide some practical design options for such shiftable layering, which we use to build some rudimentary prototypes. The first prototype is based on a simple mechanical shift. We mount 2 CFA layers on a metric bar type lens holder with one layer mounted to the static part and the other layer mounted to the moving part. One turn of the head of the screw results in a ½ millimeter movement of the moving layer. Therefore, we can achieve micron level shifts by rotating the screw by 1 degree. Our second prototype uses optical shift and can be mounted on any DSLR camera. In this setup, we focus the image on the first CFA, and then we use 2 lenses, one of which is moved slightly off-axis, to refocus the image onto a second CFA, the CFA of the DSLR camera. The off-axis lens shifts the picture of the first CFA, and by moving the 2 lenses back and forth, we can change the amount of the shift. In summary, we present the concept of having multiple switchable modes of operation in the same camera using two shiftable layers of color filter arrays.